Hello, can you guys hear me? Hello, can you guys hear me? Just type yes if you can hear me. Well, I just wanted to check how many of you joined, so just press join so that we can start. Sorry for the delay. We were facing some technical issue and because of that we got delayed. Just type joined, then we can start. Alright, Kedar said joined, Jagannath said joined. Alright. So we will not waste the time, we'll quickly start. We'll wait for 2 more minutes and then we can start for this live session. All right. Good morning, everyone. First of all, welcome to this live session on how to crack embedded interviews. If you are here today, I already know one thing about you. You are serious about your career and you don't want to leave your future to luck. So whether you are a student or a working professional or someone who is stuck trying to switch job, this session is for you because embedded interviews are not just about knowing theory; they are about structure and confidence. So in today's session, I will walk you through clear roadmap to prepare for embedded interviews, what interviewers actually expect from you, common mistakes that silently reject good candidates, and of course we will do live Q&A, so bring your real doubts. So this is not a motivational talk, this is a practical experience based session built from real interviews, real failures and real offers. So stay till the end, trust me, it will be worth your time. And one thing I want you to keep in mind throughout this session, into preparations fail not just because people don't work hard, but because they prepare without direction, and today my goal is to give you that direction. So what you can expect from today's session is I'm going to tell you exactly about the roadmap to prepare for the merit system interviews, whether your experience is 1 years or 10 years or 12 years or 15 years or 5 years. This approach is going to help you basically. So I'm going to talk about three-part proven framework which we generally follow to help people to prepare for the interview, and then what are the common mistakes we generally makes during interview and while preparing for the interviews, as well as we'll talk about how to present our project confidently so that we will know like how to prepare in the best possible manner, right? So let's start. So as per our understanding and going through a lot of engineering students basically, as well as engineering professionals who are preparing for the interviews, so we have designed a three-part into preparation framework. So we can divide into preparation into three-part, whether you are from automotive, whether you are from firmware, whether you are from bare metal, or whether you are from uh, having any background related to embedded system. It's very difficult to cover and talk about each and every skills here basically, but we can break down the into preparation into three part. So the very first part is, so this is the three layer architecture basically, so you can break down your into preparation into three parts. So the very first layer is your core fundamentals basically. So core fundamentals I will talk about, like what exactly we need to focus from the core like core fundamentals. And then second part is your role specific knowledge. And then third part is the project explanations mastery basically. So we have seen people are prepared well basically, but when it comes to explain your own project, so what we feel is they are not ready to basically, or we can say they are not confident to explain their project in the good possible way, right? So during this session we are going to talk about that, how to basically present your project in the best possible way, right? So the very first Topic is of course the C pointer. So anytime whenever we speak with people and we ask them like what is the difficult topic which you feel while preparing for C programming, so they come up and say pointer is the difficult topic for them. All right, so pointer play an important role whenever you are going to prepare for the interview. Definitely you can expect a lot of questions from the pointers. So now the questions comes from pointers, what we really should study about it. So from the pointer you should focus upon pointers arithmetic, pointer to pointer, function pointer, void pointer, and then common pointers pitfalls like a dangling pointer, uninitialized pointer, wild pointer, invalid pointer. So these are the key topics which you need to basically focus whenever you are going to prepare for the interview, right? So after pointer we have the memory layout. So definitely you can expect a lot of questions from the memory layout, and you must have seen the interview questions like what is the memory layout of a C program, and they can give you an example. Okay, so these are the variables, just let me know like from where and which sections of these variables will be settled in the memory layout of the C program, right? So you have to not just read about like okay, so these are the memory section or memory layout of a C program. So you have to practically basically practice few problems by which you can understand okay, so this variable I have created and this variable is going to this particular data sections of the memory basically, right? So you have to study this memory layout in deep so that if any questions comes in the interview you will be able to explain it confidently, right? So the second part is sorry, the third part is storage classes basically. So storage classes also like play an important role basically. And why this play, just give me a moment actually. All right, so storage classes also play an important role because storage classes you can expect a lot of questions from storage classes. So you should know what is static class, what is external class, sorry, what is external keyword basically, what is volatile. And this, like volatile keywords you will find everywhere, everyone basically talks about it, what is the volatile keyword. But when we ask what is volatile keyword, everyone just answer volatile is a keyword to basically bypass, or we can say they will say like this is to stop the compiler optimizations. But in the real world the uses of volatile is quite deep basically. So you have to know the depth of the volatile keyword, right? If the depth is not clear, then how can you make the differentiation between the freshers as well as an experienced engineer basically, right? So you have to basically understand volatile in deep. You have to know, you have to understand where exactly you use volatile in your real time projects basically. So you can expect question around does volatile bypass cache, or what exactly the instructions volatile generate which basically stops the compiler to do the optimization, and what is the internal procedure is basically followed, right? So these kind of questions you can expect from the volatiles. Then of course volatile constant also one of the top asked questions in into preparations basically in the interviews basically. So you need to focus upon that. So the whole idea is you should have good and good level of understanding of the storage classes with respect to and external linkage, internal linkage, static storage class, external storage class, volatile storage class. All right, so the next part is bit manipulation. And like bit manipulation also play an important role whenever you are preparing for the interview, right? Because being an embedded system engineer, we keep on basically playing with the registers, and when you play with the register, of course you do a lot of bit manipulations. So that is why bit manipulations play an important role during your interviews. Because being an embedded system engineer, nobody is going to expect you to write the dynamic programming or backtracking kind of questions, but at least they expect you to have good understanding of bit manipulations, right? So whenever you're practicing bit manipulation, practice these problem at least, like setting a bit, clearing a bit, toggling a bit, masking a particular bit from a given integer number, or then you have to talk about how you can shift the bits to one side or the other side basically. Then indianness of the, of course the number play an important role. So you should be able to understand like how exactly the indianness play an important role in our embedded system based project. As well as bit fields, of course you should know very well, right? So you should do a lot of practice with respect to the bit manipulations. You practice as much as problem you can practice from this bit manipulation, right? And then a compilation program. So being an embedded system engineer, if you just know like the fundamentals of C, fundamentals of C in the sense like surface level fundamentals, what is integer, what is float, what is volatile, what is constant, so that is not enough basically, right? So being an embedded system engineer, you should know the internal working of your system. So that is the whole idea is, right? So you should know the complete C pipeline. When I say complete C pipeline, it means starting from your uh, the source code which you have written until the executable, basically how that translation from your source code to the executable is happening and what exactly there in the executable. So you should have clear picture of that in your mind, and then how the linker works, how the loader works. All right. So these kind of understanding Intuit is going to expect you if you are targeting good product based companies, right? So you should have clear understanding of what happens in the pre-processing stage, what happens during the compilations, and how the linker is basically going to resolve the symbols, how the loader is going to load the program into the memory. So these things should be basically clear in your mind, right? And then structure and union, of course, when I talk about structure and union, because in everywhere in our embedded system based project we use structures and union a lot, right? So structure is basically play an important role. So in structure you have to understand, okay, so how the structure basically uh, get the data, how the structure basically occupy the memory in the memory basically, right? And then the basic of unions, like how to use the union, how to use structures, and wherever in the real world projects we use union or structure basically, and how we make a decision whether we have to go with the structure and whether we have to go with the union, right? And definitely we should practice a lot of problems with respect to the size of union and size of structures, right? So these problem will help us out to have the good understanding of basically having the correct memory layout of our structures and the union, right? Then this was about the C fundamentals which we should practice. But now the questions comes like, and every time people reach out to us and they ask these questions like, from the C programming, like how much C programming they really need to practice? Do they need to solve a lot of lead code problems to get the job in good premium product based companies? So that is not the case. Being an embedded system engineer, company just want to check your logical understanding. So that is why what they ask is, so they ask the bare minimal C programs. So I will just talk about the topics of the C programs basically which you need to practice, and then few questions I will list out which you can basically go through and you can basically practice those. So array and string, like from array you can practice like reverse array in place, reverse the string in place, then rotate array by k element, right? Find the first non-repeating element in the string, then merge two sorted array, remove duplicates from the given string, right? And then starting operations like string operations, basically you have to write your own mem key, mem copy, you have to write your own string length, you have to write your own string str functions. So these kind of programs you should practice from array and string, right? And then from pointers and memory, so definitely you need to practice a lot of program. First of all, you should have clear understanding of how to allocate dynamic memory using the malloc and calloc, when to use malloc, when to use calloc, what is the difference between malloc and the calloc, right? And how you can write your own how you can basically detect the memory leaks, what precautions you should take in your programming to avoid any memory leaks happening, right? And then in the linked list, basically you have in the linked list you should practice not the tough problem, but at least like how to detect and remove the loop from a given linked list, how to reverse a linked list, then how to merge the two sorted list, then find the middle node of the linked list, delete node with only the pointer given in a linked list basically, right? Then from the bit manipulation, as I already mentioned, you should practice the count, set bits, checks, set clear, toggle with n bits, swap using XOR operations basically, extract the build bit fields basically, and then build the mask, right? Reverse bits of 32-bit integers. So these kind of questions you can basically expect from the bit manipulation, right? And then recursion and backtracking, of course, play an important role. From the recursion you should practice like factorials, Fibonacci series, tower of Hanoi, string permutation, subset generation. So all those are the problems, these are the problem basically you can you can practice before going for an interview, right? So now searching and sorting, of course you can practice basic searching and sorting algorithm, binary sort, quick sort, merge sort, insertion sort, right? Not to focus much on this. Then stack and queue questions are also asked in embedded system interviews basically. So you can practice implement stack using queue, stack using array, linked list, and implement stack using queue, implement queue using start, right? And the this kind of basically questions you can practice from the stack and queue, right? So of course, if you're going for a merit system interviews, definitely there could be a lot of questions related to debugging. So you should basically practice like from the given program, what is expected output, or do you see any bug in the given code? So these kind of practice you should basically do, right? So system design, of course, if you are going for premium product based companies, so you can expect system level system designs questions basically. And system designs questions, you will only have good understanding of system design questions if you have really done the practice of those questions, because at a time design a new system is quite difficult, right? So better to practice few system design problems before going for an interview. Let's say so implement debounce logic, crc checksum implementation, simple scheduler simulation, producer consumer buffer, register manipulation exercise. So these kind of system design problems basically you can practice, right? So then this was about the C programming. So next is core embedded fundamentals. So this I'm going to talk about the very first round of these product based companies. Basically in the very first round they will test your C programming fundamentals and the core embedded concepts. So from the core embedded concepts, irrespective of your domain, whether you're in automotive, bare metal, firmware, or any field you are working of a merit system, so you should know at least these topics basically. You should know ISR, how the interrupt service routine works, how to handle the interrupt priority and interrupt latency basically, debouncing logic, watchdog timers, our overflow, boot process basics basically, memory map registers, polling versus interrupt versus DMA. So all those things you should basically practice from the core embedded concepts, right? And then this was about the generic stuff which we talked about. Being an embedded system engineer, you should know C, you should know embedded system fundamentals, but now we will focus upon role specific, what you need to prepare according to your skills or your resume basically. So let's say you are an RTOS engineer, basically you have done a lot of work on RTOS based subsystem. So you have to prepare well on the RTOS fundamentals. So when I say RTOS fundamental, it's like what is an RTOS, what is the task and thread model, how does the task scheduling works in RTOS, so that we can have the deterministic behavior of each and every task, right? And then what are the different priority levels, what are, how the determinism and latency works in case of RTOS fundamentals, right? And then of course synchronization also play an important role. From synchronization you should practice what is mutex, what is semaphore, when to use mutex, when to use semaphore, what is the difference between mutex and semaphore, what are the event flags, what are the massive queues, what are the spin locks, right? So spin locks are rare in the RTOS, but you should have basic understanding of the difference between spin lock and the semaphore, right? And then of course from the interrupt handling you should know like how interrupt is basically handled in the RTOS, how the ISR plus deferred work in RTOS, right? And then how the context switching works in case of ISR, how the nested interrupt handling works in case of RTOS, right? So from the memory you should practice like how in RTOS basically we create one stack per task, how the heap fragmentation comes into the pictures, how the static versus dynamic memory allocations works in basically RTOS based project, right? How to allocate memory, what are different way of basically allocating the memory, right? So these are the basic fundamentals which you should practice from memory. Then timing, of course, what is jitter, what is deadline miss, like, and how to do the response time analysis, and then hard versus soft real time systems basically. So these all things you should practice, right? From RTOS debugging, definitely you should practice like how to detect a deadlock, how to basically find out the priority inverse, like you should basically focus like how to understand the priority inversion, like what is the priority inversion and what is the need of like how this priority inversion happens and how we can avoid this priority inversion. So you should have the clear understanding of all these fundamentals. And depending upon your work experience, basically if you are into performance, then definitely you should understand how you can basically load, measure the CPU load, right? And then stack overflow debug, all those things you should have in your mind, right? From the design problem, as I always mention, like you should practice few design problems before going for an interview. So you should practice producer consumer problem, circular buffer, and then you should able to design a event driven architectures, timer callbacks. So these are just the highlights of few embedded system problems which you can practice, not the not I cannot basically list all the problems here, right? But these are just to give you the highlight, like what kind of design problems you should practice before going for an interview, right? So till now, whatever we spoke about, this was about RTOS specific interview preparation. Now, let's say if your profile is Linux kernel and device driver based profile, basically. So what you should prepare. So definitely your profile is Linux kernel based. So from the kernel fundamentals, you should practice kernel architecture, like how the user space to the kernel space transition works, how the basically communication between user space to the kernel space actually works, right? And then how the system calls basically works internally, how the switching from user space context to the kernel space happens whenever you are basically invoking a system calls, right? Then kernel modules of course play an important role, how the kernel module is created, how the kernel module is basically loaded at the runtime, and what to how to basically load the kernel module, how to unload the kernel module at the runtime. You should clear about device driver model which is followed by kernel, and then of course what is process thread, what is kernel thread, what is the basic difference between process thread and the kernel thread, right? So these kind of fundamentals you should have in your mind, right? From the memory management point of view, you know, like Linux kernel has very complex memory management subsystem, so you should know what is the difference between kmalloc versus vmalloc, how the page allocator works in Linux kernel, how the slab allocators works in Linux kernel, what is high memory, what is low memory, mapping user memory by using mmap or other way possible. So then copy to user, copy from user, so these all fundamentals you should know. And when I say copy to user, copy from user, it doesn't mean like you will just know, okay, so copy to user is used to copy the data to the user, copy from user is basically used to copy the data from the user, right? This is not going to work in that, like this is not going to help. You should know the actual understanding, like how exactly this copy of data works, what are the challenges we have whenever we are copying the data from the user space to the kernel space or kernel space to the user space. So you should have clear understanding of that in your mind, right? And then from the device driver basics, you should have clear understanding of what is a character driver structures looks like, how you can basically write your own IOCTLs in your drivers, and how you can implement your own functions in your driver, basically how you can load your driver, how you can unload your drivers, and how you can compile your driver statically. So these all fundamentals you should be clear about. And then of course synchronization play an important role in any Linux kernel and driver based interviews, basically. So with respect to the kernel synchronization, you should know the spin lock, you should know the mutex, semaphore, completion variables, atomic operations, basically you should have clear understanding of. Then RCU, of course you should know like what exactly the RCU based synchronization and how does it work, right? From the interrupt handling point of view, you should have clear understanding of how the request IRQ work, what are the parameters which you need to pass while requesting an IRQ from the Linux kernel, and then how the concept of shared interrupt basically handled in Linux kernel, how the top half and bottom half work, what are the different way of basically uh, knowing this bottom, what are the different way of handling your bottom half task, basically soft IRQ task, let work queues, and then in which scenario you should use which kind of bottom half, so that also play an important role, right? Then of course kernel debugging, you should know about like what are the different way possible for you to debug the kernel by using printk, dmessage, dynamic debug, or maybe trace32, then gdb, and then kgdb, crash dumps, address sanitizer. So all these tools you should be aware about, right? Of course file operations is also an important part. You should know like what how the file operations are handled in Linux kernel, how the virtual file system comes into the picture in Linux kernel, and how that virtual file system is basically managed in Linux kernel, right? And then I always suggest to all our trainee, like before going for any interview, I would recommend you to go or have a walkthrough of the existing code in the mainline kernel of a few drivers, basically, so that you will have good level of understanding like how the drivers is actually implemented, and you will understand the process of implementing a driver from there. So you can practice few basic peripheral driver, let's say GPIO drivers, and then I2C driver, SPI driver, UR driver, DMA driver basics, right? Then this was about the fundamentals preparations with respect to C, RTOS or Linux kernel. Now comes to the project and resume preparation part. So your project basically explain 50% of your interview success basically. So most of the candidate I have seen, they fail here basically when it comes to explain uh, their project. So we suggest people to follow 5 point framework whenever you are explaining the project. First of all, explain the problem statement, like what was the problem which you fixed by using by your own implementation or the development you have done. And then you should also explain the system architecture of your project basically, right? And then what was your exact ownership. So we have seen people will simply tell, okay, so they know your driver and they know SPA driver, but what have you done in your project? What was your impact? What impact you basically brought while working on that particular project? What was your exact ownership as part of that particular project? So you should be able to explain it clearly, right? And then technical depth, you should explain like, okay, so this was the problem and you followed these particular fundamentals of Linux kernel or RTOS and you fixed these issues, right? And then what was the challenges you faced while fixing these issues or maybe working on the new features which you are currently developing, right? And what to avoid during explain the project. Basically you should avoid reading the resume first of all, right? We have seen people will start reading the resume, so there is no point of reading the resume because interviewer is already aware about your resume. Basically he knows what exactly written in that resume, so he wants you to explain the work which you have really done in your project, right? So you should explain that, right? And you should not talk about irrelevant modules, even the modules you have not touched during your project development, but still if you are talking about those modules you should ignore that, right? And then of course a lot of explanation. We have seen people explaining a lot of stuff, a lot of topic they start explaining. So you don't do that because sometimes people feel confused, even the interviewer feel confused with a lot of information if you will start sharing it, right? So don't do that. Now what are the mistakes which most of the candidate makes. So the first mistakes we see is like they, instead of understanding the concept, they just learn the concept or cram the concepts, like looks like let's say if you will ask what is volatile, so they will simply tell volatile is just to stop the compiler optimizations, right? But if you will ask one more question, one cross questions of that, they will not be able to answer that, right? So don't remember the thing or don't just memorize the answers, instead of focus on learning the concepts, right? And now the other thing is not preparing on basic C questions. So we have seen people who is having 10 years experience, 12 years experience. If you will ask them to write a simple string reverse program or linked list reverse program, they will not be able to uh, do that actually. And why this happens is because they have not practiced the C, thinking like, okay, now they are an experienced engineer and they don't need to much focus on basic C questions basically, right? And then they don't do much debugging practice. So debugging also an important play an important role whenever you are going for interview. And then of course you need the good command on the fundamentals with respect to C, RTOS or Linux kernel depending upon your profile, right? Now the big questions comes is how to prepare. So till now we have understood, okay, so these are the preparations or this is the direct roadmap, a clear roadmap which we have to basically go through. Now the questions comes uh, what or like how to prepare. So that is a problem which we have seen throughout the years, even though when I was working in the industry. So I have seen this issue, like even though I am experienced of 5 years, 7 years, 10 years, but when we go for preparing for the interviews, so to go to depth of the fundamentals is it's quite tough basically, because we have to refer to the random videos, we have to refer to the random document which is available on the internet. So it takes a lot of memory as well as a lot of our bandwidth. So that is why we basically created a structure into prep boot camp for you. So this boot camp which we are going to start from this is boot camp 3.0. We have already completed boot camp 1.0 and 2.0, right? So we are going to start embedded system into prep boot camp 3.0 from 16th February. And as part of this boot camp, definitely you will have complete interview roadmap. We are going to cover C, RTOS, Linux device driver. So we are going to cover each of these things in detail with the interview questions and answers. So whatever we talked till now during this webinar, everything we are going to cover as part of this embedded system into preparation bootcamp 3.0. So how this works is every week we are going to basically share 3 recorded sessions per week, because most of the people who join this boot camp, they are working professionals basically. So live sessions basically don't work for them. So that is why we kept three sessions, three recorded sessions per weeks, which you can complete as per your own convenience basically. And on weekend we conduct the live doubt session, so if you have any issues on going through any of the session, you can just ask your doubts in the live doubt sessions, as well as you will get a private community access, so there also you can ask any of your doubt at any time, right? So lifetime access to all the content, so whatever the topics or whatever the sessions will be shared with you, so everything, whatever the resources will be shared with you, so that will be available to you for the lifetime, right? And then as part of this boot camp, you will be able you will be having access to a lot of assignment as well as practice questions, which you can practice to enhance your learning or prepare well for the structure, like into preparations, right? And so who is this boot camp for? So even though your experience is 1 years, 10 years, 15 years, this boot camp is going to help you, because the fundamentals which we are going to talk about in this boot camp, that is definitely going to give you the good confidence while preparing for the interviews. If you are embedded engineer, firmware engineer, RTOS engineer, this boot camp is for you. If you are Linux device developer beginner or pro, definitely this is going to help you. And then if you are switching from testing to development role, then also this boot camp will help you, because it will give you the clear roadmap how to prepare for the interviews and how to target the premium product based companies, right? So these are the few success stories from our previous bootcamp batches. So we have people who got placed in Qualcomm, Nvidia, and with 100% hikes as well, right? So these are the few success stories which we have listed out here, right? So now, because you have joined this webinar, so you can, I'm just sharing the bootcamp link in the chat description. Basically, if you want, you can go through it. And because you joined this bootcamp webinar, so we are offering you a discount of 20%, which will be available only for next half an hour, right? So you just use this coupon code which I am pasting in this chat basically, right? So that's all I wanted to cover as part of this webinar. Now let's say if you have any questions, you can just shoot your questions so that I will be able to answer those questions. Okay, so someone asked, can you suggest some project to practice RTOS? So if you want to practice RTOS, if you even though if you don't have any hardware with you, you can use the RTOS simulator. You can practice, like let's say you can write your small mini kernel, I would say, which will have a scheduling algorithm, basic scheduling algorithm implemented. So these kind of project you can implement by your own. Then you can also implement a simple data logger system. So basically you have one application which is generating some logs, and then you have few processes or the thread which is basically logging that data which is coming from that particular sensor. So these kind of basic projects which you can basically uh, practice, right? And every time people comes and ask, like, do they really need hardware? Of course, if you have the hardware, that is the good thing, because you can play with your hardware, you can do a lot of stuff on the hardware. But even though if you don't have hardware, don't basically be sad, because you have nowadays you have a lot of simulations for RTOS, as well as ARM processor available. Maybe you can QEMU, if you know the simulator, you can use that, and you can practice lot. You even in fact you can do a lot of practice there basically, right? So resources are not a problem. It's just you have to spend some time on that and practice for it, right? So if you have any queries, just let me know. We will be answering those queries. Okay, so there is another question. What are the companies offer embedded roles? So nowadays there are a lot of hiring going on in embedded companies. Basically, you can um, go for interview in all these companies. You can target Nvidia, you can target Qualcomm, you can target AMD, you can target MediaTek, right? And then of course you have automotive companies as well, Continental, Bosch, and all these companies also, they are also hiring, right? Even though people reach out to us and they say they don't see much hiring in the automotive domain, but this is not the case. Indian EV sector is currently rising, and you can see a lot of basically contributions of the MNCs being there. so you can target those companies. So you should not worry about uh, like whether there is hiring going on currently in the market or not. Definitely hiring is going on, even the big product based companies are hiring for that. Okay, so the next question is, I am working as an embedded Linux application developer. So any suggestion for me to prepare for interview? And for the application developer, how was the job market? From the application developer, if you are preparing for the interview, definitely you should have good programming skills. Let's say if your main work revolves around C, so definitely you should be very clear about C fundamentals as well as C programming you should practice. I'm not saying you practice the lead code level basically competency with respect to C programming, but at least go through the basic fundamentals and the basic programmings, let's say linked list, stack, queue, array, string, so that you should practice, right? And then RTOS fundamentals or any operating system fundamentals on which you are working, that you should clearly know about it, because that is going to help you out, right? I'm correcting the coupon code, which is webinar 20, not the 30 basically. All right. So, and then you ask like how the market with respect to the application developer for embedded system based project. Definitely, if embedded system people are being hired in these companies, so application role also will be there, right? So if product is being developed, so applications also will be developed for those products, right? So market is quite same for if you are working on low level layer or driver layer, firmware layer, or an application layer. So definitely you can expect a lot of hiring going forward, even in the current market. Even though few companies are failing, like let's say we have seen the bad time for Intel, they have laid off many people. But if a company is not doing if company is not doing good, then definitely next company or the other companies are doing good. Maybe Intel was not doing good, but other companies like MediaTek and Nvidia, they were doing really good. Even the Broadcom was doing really good, right? Now the next question is, this course is only for developmental? No, this is not the case. Even if you have testing profile, but still if you will target any interviews, then definitely, even though you are working in testing domain currently, but definitely when you go for the interview, they are going to expect to write few C programs, as well as they want to know the OS level understanding, whatever the system level understanding you have. And depending upon your experience, let's say your experience is 5 years, 7 years, or even more than that, they can also expect few system design level problem from you, right? So being a testing engineer, it's doesn't like you only know to test the system. Before testing any system, you also should know the working or internal of that particular systems, right? Knowing system in a better way is going to help you to become a good tester, right? So any other questions you have, if you have, just let me know, I will answer those questions. So even though you are from testing, even though you are from validations, this course is going to help you out, because this course is going to help you out in brushing up the fundamentals um, with respect to C, with respect to RTOS, with respect to kernel, or mock interview also part of this boot camp. So it is going to help you out to basically know your current status, and it is going to guide you how to practice well and what to practice well basically. So the next question is C++ also need to prepare? It depends actually. If your roles revolves around, if your current roles revolves around C++, then you can practice C++ as well. Let's say if you're working on modeling side, or if you're working on the hard layer side, where you need C++ to develop or do the development in your project, so definitely you should practice the C++. But it is not basically strict like you should practice C++. It depends upon your current job roles and the job roles for which you are appearing for the interviews. So we are starting this boot camp from 16th Feb. So most of the enrollments are done. So if you want to be part of this boot camp. So this is the last chance for you to register for it. So I would recommend you to register for it. Okay, so the next question is, I'm having 1 year career break. Does it affect with 3 years experience? So it depends upon company to company. Some company doesn't mind it. Like if you are having some niche skill, or if your skills is uh, good actually. So in that case, you can like companies will not mind it if you, even though if you have this career gap basically. It depends upon company to company. If they can find any other engineers which is basically not having any gap and he has very good skills, then they will um, basically prefer to hire him. But if you are having a good skills, if you performed well in the interviews, then definitely they can hire you, not an issue. All right, so I think if you don't have any further questions, we can drop off for the today. I will just wait for 2 more minutes. If you want to ask any question, you can ask questions, otherwise we'll drop. Okay, so the next question is AI affect embedded job market, and what how to adopt AI basically. So this question is asked a lot, like many times whenever I interact with the engineers, so they ask the same questions. So first of all, being an embedded system engineer, you are working hard with the devices and the lower layer of the most of the product basically. So in the current scenario, we are like AI is still away from taking away our job basically. So this is the fear which everybody is creating in the market. So AI will take your job. It is not going to happen. AI can become your assistant, maybe analyzing the logs, or maybe writing or doing the automations. Definitely AI can help you out in that. So you don't worry about AI effect on your embedded system jobs basically. I- It's okay. Few front end jobs is taken off by the AI, because front end process can be automated, but finding the bugs in the real hardwares and then working with a lot of simulation analyzer, it's very difficult for now, at least in the current trend for AI to do that. So you should not worry about AI effect on the merit system based jobs basically. And now the questions come how to adopt AI, but you should utilize the tools, AI tools basically, to help you out for being an embedded system developer. Okay, so which tool help us as embedded developers? So there are a lot of tools in the market, even though for doing coding also, right? You can use Chat GPT as part of inbuilt to your code editor. It can help you out. Even for the GitHub also, if you have now AI tools available, which will help you out while managing a lot of project on the GitHub. So these are the tools. We are going to come up with the new sessions basically, in which we are going to talk about what AI tools embedded system engineers can use to optimize their work. All right, so there is a question from Parveen Pawar. Is working as post silicon validation engineer and work mostly revolves around execution and Python automations. How this course will help to move towards developer role? See, the thing is, this course will set the basic fundamentals for you basically, so that you will have good understanding of the basic fundamentals of C, RTOS, and then a few system design problems, right? So it will set the base for you. Then depending upon how much effort you will put in further, because you want to switch from automation to the development role, definitely being an experienced engineer, you should practice few projects, right? So once you have fundamentals clear in your mind, you can utilize that knowledge for practicing few mini projects at least, and then those projects will be helpful for you to basically explain your experience in the interviews. So definitely this course will help you, at least giving you the fundamentals base. Right, so I'm waiting for the next questions, and if no question, then we'll drop off in next 2 minutes. All right, thank you so much for taking time out from your busy schedule and joining this webinar. Thank you so much for joining this webinar. I hope to see you soon in the upcoming boot camp. Thank you so much.